And then what Google also had done is, it's a good thing that they have done. They have developed a sample program and implemented the application in C. There is one person by name McCormick who has commented each and every line of what Google has presented, and that would also help you if you do not understand C very well. It will help you understand the concepts, and then how they really optimize the weights, how they use this subsampling mechanism, negative sampling, and also hierarchical model in the softmax values. So, I like you to go to this website, download this. You do not have to really do anything. If you have a C compiler in your desktop, you just have to run the make file and it will do every job for you. It will download about 1 billion words and then train the neural network for those words. Okay. And it's very simple to use. So, once you finish it, you will have executable, and there are scripts available for you to run. Okay. So, both for Windows, Mac environment as well as Linux environment. And then try to run some small example. There is a word to wik.sh if you are using a Linux box, okay, or Mac, or I think it is a bat file in the Windows. So, you will find an executable script in this name, and when you run the script, it will ask you to input some values. Okay. So, it will ask you give me the word. Okay. So, when you provide the word here, what I have done is I have given automobile as the word, and then it tries to find out all the words that are somehow related to this word. Okay. How does it find? I think that the entire exercise is all about that, right? The word is identified by the company it keeps. Remember that quote from Firth. Okay. So, that means this word has context which are available across the entire 1 billion word that it downloaded. Based on the context, the relationships are established and the words are found closer to each other using a cosine distance. So, in this case, I think I am not sure about the vocabulary size. It is pretty huge though. Okay. So, when you do the cosine distance, you have to find the cosine distance for the entire how many ever vocabulary that you have, and then list them in the order. Okay. So, here you have the descending order of importance. So, you look at the words that it had picked up: automotive, okay, and then manufacturer. So, many places it would have encountered the context related to the automobile consisting of manufacturer, the name of the manufacturer, all that, right. And then it found that a car is related to this. The plural is associated here. The name of the company is associated with this. And then dealerships. So, this word again is associated that you are able to appreciate the word vector model, right. So, it is not just about the meaning of the word alone, it is about how it really work along with the other words in the entire corpus. And then motor, Benz, automaker, minivan, Volvo, Toyota, DKW, Daimler, Chrysler, Bugatti, Porsche, Maybach, and cars. So, how wonderful it is, right. So, without really using any dictionary that is available, only based on the data that is provided to the system, it is able to really relate a given word with the other word just based on the context that it found, right. And this context is what we can call as a pattern that is available, and the system has identified the patterns which are close to the word automobile here. So, remember when we spoke about the dimensionality reduction, this exactly it is. Now, I can place all of these words in one dimension, okay. So, all of these could be in this dimension. So, instead of keeping them in so many different dimensionalities, right. We have reduced the dimensionality using this model. So, please read this. This is the core of the machine learning part in the natural language processing, and many applications are developed based on this. All right. There is another important implementation that is available called GloVe. So, this is from Stanford. So, you can also take a look at this and then see how this is implemented. Okay. And then maybe sometime later I will also talk about what is the difference between the word-to-vec and the GloVe model. And again, if you go to the website of GloVe, they have provided a lot of things for you as well. So, you can also instead of creating your word vector using the corpus, which is a very time consuming process on a small desktop, you can download the word vectors as well. The word vectors are available with 50 elements, 100 elements or 300 elements. I am not sure what else you have there. You can use those word vectors also for your application directly. So, the output of what we have done so far is going to be the word vectors for all the vocabulary that we have. So, that means every word now has gotten the relationship among all the words, okay, wherever possible. And instead of creating that, you can also use the ready-made word vectors that are available from GloVe or from the word2vec, and these are all available for free and you can use it in your applications. See, one of the applications that I demonstrated briefly for sentiment analysis earlier, I used the word vectors from GloVe. This we will be using in the subsequent lectures from now onwards. The meaning of the word vectors, all those things. Now you have some ideas, and then to extend the ideas, now we will take it to how do I really encode a sentence? Okay, how do I encode a paragraph? How do I identify important phrases in a given paragraph? How do I use the sentences that I have encoded so that I would be able to translate from one language to the other? So, all involve the basics of word vectors. Try to read as much as possible in this part. This is the fundamentals of the modern natural language processing.